Guys, we're given question 6. Read as follow. In South Africa, the transportation of goods by trucks adds to the traffic problem on our road, right? So then there says a 10,000 kg truck. This is a mass. 10, 10, 10 10,000 kg truck travels up straight and incline road uh, of the land. We're given the land there, which is 23 meter. Here it's a truck travels this length there at the constant speed, as you can see, at the constant speed of that of 20 kilometers per hour. 20 kilometers per hour, then reaches the top, reaches the top, which is its unknown height. We don't know that height. Then say the total work done by an engine, total work done by an engine of the truck to get there is 7 times 10 to the power 5 joules, right? The the engine is the one obviously that propelled this truck to reach the top. Is that work that take place there on an engine. So the work done to overcome friction, we have work done to overcome friction, which we have two non-consecutive force. We have two non-consecutive force there. As you can see, this is a non-consecutive force, this is a non-consecutive force. Say 6.1 says we have calculate 6.1.1 calculate the height h reached by the truck at the top of the road. We want this h, right? How can you calculate that h? It's fine. We have 7 point. Oh, what is the 6? We have 6.1.1. Here we're given 6.1.1. We want to calculate the height reached by the truck at the top there, right? So we use WNC formula because I have non-consecutive force. WNC formula, which is no change in EP, which is potential energy plus change in EK. We know that we have two non-consecutive force. Here our non-consecutive force, it's a force applied by the engine and the force of the friction, right? Remember I said non-consecutive force, right? If you're given the non-consecutive force, you will focus on will be force like friction, will be force applied, or force of friction. We'll have friction, yeah, things like that. Friction, tension, these are non-consecutive force. But the consecutive force, yeah, it's equal to it. It's a gravity. Gravity, it's a consecutive force, not non-consecutive force, right? So this is what we have. So WNC, imagine, remember the force of the engine is applied in that direction and cause the truck to propel, right? You see them. Here is the force of the engine. Then we have the work there, which is 8.5 times 10 to the power 4. What is that work? Is the work of uh, the friction, which the friction, we know the friction always acts in the opposite side. The force of the engine acts there. Remember, this will be an engine. Here we'll have a friction. So we'll subtract the two. So force applied, we know that of an engine, right, is the one that applied would be 7 times 10 to the power of 5 minus 8,5, right, times 10 to the power 4, which is equal to let me first okay, let me first expand the formula for you guys. I can say W non-consecutive force, this is same as 1 over the same as potential energy is mgh final minus mgh initial plus kinetic energy is 1 over 2 mv squared final minus 1 over 2 mv squared initial, right? So this is what we have there. Then our non-consecutive force will be 7 times 10 to the power of 5 minus the one of the friction, which is 8.5 times 10 to the power of 4. Here it is. Remember guys, we have these values there. We have these values. These are the values we have. Engine 1, the one of the friction. It's a work right then. It's equal to, we have mg. We have mg, the mass. The mass they said is 10,000 kg. Remember, it's 10,000 kg over gravity is 9.8 multiplied by final height, whereby the final height we don't know. It is h. It is h minus. Yeah, we don't know it. Final height we don't know them. We don't know. It is h minus 1,000, 100,000. 10,000, sorry, multiplied by 9.8, right? Then multiply the initial height is 0, so this will simply cancel it away because 0 will cancel all of this, so there's no need to write that. So we'll have plus 1 over 2 here. The mass, I can factor, I factored 1 over 2 and factor the mass. The mass is 1, it's 10,000. V final there. Remember, it's at constant speed. Oh, it won't change. Remember, V final will be the same. It won't change, will be that. If it is, imagine if something is constant, does not change. Imagine if you're traveling at 5 meters per second. Remember, if you have final minus initial will be 0. Imagine if I substitute the 5 minus 5, simply 0. So also this one, since it's at the constant speed, also this kinetic, all of this kinetic will be 0, will be left with 0. So here we'll simply have 0 because when you substitute that will be 0. This is what actually we have there. This will be 0. Will simply equals to 0, right? So if you want that, our left hand side will have 6.15 times 10 to the power of 5 is equals to, multiply these two, or not just, or even if you don't multiply, just write them as they are. You have h, then divide by this, right? This and that will cancel. So what will be h? Therefore h will be 6.28 meter. That is our h, right? So we found the height there, which is 6.28 meter. So 6.1.2 says the instantaneous power delivered by the engine. One, the power delivered by the engine, right? 6.1.2, 1, the power. Hopefully you know that power is equal to force multiplied by velocity, because you're given what? Constant speed or constant velocity. So we'll use this formula. We must use this formula. Must use this formula. So you see here we're supposed to have the force there. If you may check, we're supposed to have a force. And then that force, how can we get that force? The force there. Remember, I want the force that applied, the force that is on the force of an engine there. Remember, the force is generated here. The force of an engine, there's a force, remember. There must be force there of an engine that allows this thing to work, to goes up the incline, but also there's work. But we're given the work for that engine, right? We've given the work for the engine. So as you can say W because it's a work. I will use the work formula, which is force multiplied by change in X multiplied by cos theta. Right, the work you've given there, which was 7 times 10 to the power 5. We want the force, the displacement there. This is the displacement, which is 23, right? The distance traveled there. This will be 23 cos goes in this direction, and then also the object goes in this direction. What will be the angle? The angle will be 0, right? Because if imagine the object goes there, and also the work of this causes to goes there, the force also goes up, so this will be 0, right? Cos of 0, what is cos of 0, which is 1. This will be cos of 0. Then 7 times 10 to the power 5 f by the 23. This is the same as 1. Cos of 0 is 1. Then can divide here by 23, both sides. Divide there by 23. We'll get that f is equal to, if I punch this, get this is 3,04 times 10 to the power 4 Newton. Force is measured in Newton. Then this, it's our force, right? This is our force, right? So we have the force. Now we're supposed to calculate the power. We are not done. Now let us calculate the power. Yes, we know that power is equal to force multiplied by velocity, but the velocity here, it was given as note there, your SI units, 20 kilometers per hour. Be careful there. You've given this as 20 kilometers per hour. So you must change first the kilometer. We have 20 kilometers, same as 1,000, right? You multiply this by 1,000, right? Then 1 hour, we have 1 hour is equivalent to 1 hour. When you change it to seconds, you will say 1 hour. When you want to convert this, when you multiply by 60, it will change to become minutes, right? Then you multiply up by another 60, will change to become seconds. So we'll divide this by 1 times 6 times 60, right? So we've changed this to be what? To be seconds. Remember, this must be in seconds. Then this will be in seconds. This velocity. So we'll multiply by this. This is our velocity there. So power, you would call the force that you've calculated multiplied by the velocity there, 20 times 1,000 over 60 multiplied by 60. Then the power, if I punch this accurately on your calculator, you'll find that the power is equals to 1,6 times 10 to the power of 6. It's measured in watts, right? It's measured in watts, whereby we know that a watt is the same as joules per seconds of in watts. So we have found that. So last question, which is 6.2. What does 6.2 say? Says arrestor bands are constructed as a safety measure to allow trucks to come to rest when their brakes fall whilst going downhill. Try to design fixtures of such arrestor bands. So here we have arrestor bands are constructed as a safety measure. Remember, as a safety measure, it's supposed to be saved to allow the truck to come to rest when it's falling down. Imagine if this thing, we allow this to become saved. If it's like this, it's more steep. You won't if you are driving, this cannot be safe. But if you try and reduce it, like and become light, you see, this will accelerate nicely. The truck will accelerate nicely for an argument's sake. So yeah, and then if we reduce friction, we'll decelerate it nicely. So um for that to be safe, I can say um the okay, they ask us what should be arrestor pens are constructed as, how to design. One, the design, or this designer of these things, they must be, I can say they must be long enough. They must be long enough. If they are long enough for vehicles, right, for vehicle to stop. You understand this? Comma then. Then the second point, what can I say? The surface must provide sufficient, let me say, sufficient friction. Yes, if you can, sufficient friction will be nicely like, yeah, like sand things. Let me just say like sands, like sand. So yeah, this is the reason. Maybe you may come up with your own reason, but so far this is my reason there. So yeah, this is what it is, guys. So thank you guys for watching, right? Please do not forget to subscribe to my YouTube channel and click that notification button so that we'll notify whenever I post a new video. All the best.